Hello and what's up to you all, Mindsetters? My name is Abram. It is a lovely Thursday and you know it is time for Geography, proudly sponsored by Macmillan. Today I'm with Cameline and we're here to learn more and learn extra with you guys. Cameline, how are you?
Abram, hi. Welcome, guys. It's an exciting episode today. We've got cross sections, a section that you've been asking for, and today we're going to manually construct a cross section. So guys, get your topographical maps, get your rulers and pencils, and we're going to go for it today with a manual construction of a cross section. Abram?
Awesome. Well, to learn more today, we've got exciting news for you guys. We're giving away these awesome Casio calculators. All you need to do is to download or view your notes and then do the test yourself questions. Submit your answers in the form that is provided via Facebook. It is on facebook.com/learnextra. Like the page, share the page with all your friends, your classmates, even your teachers. And you can also follow us on Twitter @learnextra. This is where we learn more and learn extra. More details are on Facebook. Let's do this.
Thanks, Abram. And guys, today, cross sections, let's look at a focus of what we're going to do in terms of skills today and what are the objectives of today's lesson. In this lesson today, we will be focusing on the following: applying skills in map reading to determine simple cross sections. We will determine landforms and contours, example, steep slopes and gentle slopes. We should be able to identify these on the cross section. Develop key skills in a step-by-step sequence for cross sections on topographical maps. And lastly, before, sample questions to help you practice and apply key skills in cross sections. And lastly, as always, we will look at useful hints as well as tips in applying these skills. Now guys, in order for you to understand cross sections, you must have topographical maps. These form the emphasis of construction in any section of a map. We're going to look at what is a cross section. To understand a cross section, but before we go there, I want you to look at today's challenge question. Today's challenge question culminates in the past few lessons that we've done, and I want you to answer the following question. Why is using a globe important to a geographer? A globe, just like a topographical map, is the tool which is used by geographers. But why is it important for a geographer to use a globe in everyday understandings of maps? This is your challenge question, guys, and we will answer it at the end of the show. Let's get straight into it and look at cross sections. So, a cross section is the side view or profile of an area of land. So our focus is the land surface, and we will be looking at a side view or a profile view. Why is this important? Who is it important to? Cross sections are dealt with on a daily basis for climatic purposes. Remember, in your climatology in grade 12, you have studied valley climates as well as city climates. Specifically in valley climates, anabatic and katabatic winds, which flow upslope or downslope. Once we draw a cross section, we will be able to determine the climate of that particular region dependent on the slope. Construction. My budding civil engineers, guys, those of you that are going to do civil engineering after matric next year, cross sections becomes one of the focus areas in your degree. Cross sections assist in construction industries. Why is it important? Because every construction worker needs to ensure that he has a physical view in terms of the side or profile view of the landscape before any building can take place. Agriculture. Most farmers in South Africa look at the type of land surface, either a gentle slope or a steep slope, in order to farm. Remember, farmers tend to work on gentle slopes. Why? Flat areas are easily farmed rather than steep slopes. So, when we're looking at agriculture, another important aspect of cross sections. Drainage. Simply put, guys, this simply means that steep slopes faster moving river systems, gentle slopes, lagging behind, slower moving river systems. These influence the nature and makeup of the natural vegetation in a particular region, in our cases, on topographical maps. Environmental conservation. In any environment, conservation is by far one of the most important aspects on maps. We must be able to see through a cross-section how environmental conservation is taking place. These are some of the key aspects in today's lesson that you will be using in order to ensure that your better understanding of cross-sections is going to assist you to know exactly what it is that we want to achieve, a cross-section or profile view of a landscape. The first thing that we're going to look at today is in terms of what is and how is a cross-section, or how do we construct a cross-section. In order to do this, the essential elements of any cross-section is a topographical map. What do we do with a topographical map? Let's go and see how to draw a cross-section using a topographical map. A cross-section shows the actual shape, very important, of the land between 2 points on a map. Now, in this case, you should remember that your questions are directed at 2 points on a map. We have got a rough sketch of a topographical map. And when you are asked to draw a cross-section, you will be asked to draw that cross-section between 2 points on any map. Let's look at the sketch and see what is required. In this particular example, we're looking at point A and point B. Between these 2 points, you will note that there are contour lines that run across point A and point B. What is important for you to remember is that the first step in identifying the cross-section is to ensure that you are drawing a line between the 2 points, right? Note the following. Each of these contour lines have specific references, and these references are what we call contour intervals. A contour interval is the distance between two lines, which you, on your topographical map, must be able to identify. So in this case, you will note that the distance between 1040 and 1060 is 20, and our unit of measurement is meters. So our contour interval, the distance between two lines on a contour map or topographical map, in this example, is 20 meters. Why is it important to establish this? Because when we construct a cross-section, we will be working with vertical as well as horizontal axes, and we must determine initially on that map what is the contour interval. Let's look at it. A cross-section is plotted on a graph with the horizontal distance between 2 points shown on the x-axis and the height of the contour lines shown on the y-axis. So immediately you should know that a cross-section is a graph. You will be required to construct on an x and y Cartesian plane a cross-section. What is on your x-axis? Remember, the distance between the contour lines. What is on your y-axis? The contour interval, which we've established as being 20 meters. On most, if not all, South African topographical maps, 1:50,000, your contour interval is always 20 meters. And again, remember, the contour interval, if we go back, is the distance between two contour lines. Let's move further. The length of the horizontal axis will be the distance between the 2 points of the cross-section. The scale of this axis will always be 1:50,000 on the topographical maps. This is a standard procedure. X-axis always. The scale ratio is 1:50,000. Where do we get this from? on all South African topographical maps, your scale is 1:50,000. And from there, we are able to determine the x-axis. Let's look at the y-axis. In terms of the y-axis, you should note the vertical scale, which is your y-axis, of the cross-section is either given to you in the question, or you will have to choose a suitable scale. Example, 1 centimeter represents 20 meters. What this simply means is that 20 meters is taken from our contour interval, which is the distance between two contour lines. The 1 centimeter will determine our construction, as you will see later on when we are manually constructing a cross-section. Moving further, the vertical scale is the number of meters we go up as we move along the slope. What this means is between the 2 points, A and B, you have various contour lines. What you have to physically look at is the highest height as well as the lowest height. When we do this, we will be able to determine how high our contour interval is going to take us on the y-axis. From is always on the left. When we look at a question today, you will see that the question will require us to draw a cross-section from one point to another point. What does this mean? In this example that I've shown you, we've got a cross-section from A to B. That means our cross-section has to start from A and move on to B. Let's look at the next point. The first step in order to draw a cross-section is to place a strip of paper along the joined line. The same cross-section that we've got, there's our point A and there's our point B. Note, we've got our contour lines that are moving across. However, once we place a strip of paper across, we are able to determine and mark off each of these heights. These are contour heights. And note, the distance between each of these lines is 20 meters. And from there, you will see that what we do with the strip of paper is mark off where it crosses the line between A and B. Let's look at the additional information. Contour heights are marked along the edge of our strip of paper. In this case, note, our strip of paper is this particular section which is placed over the map. The procedure, mark off the actual contour lines and label them with the heights clearly. You'll note that these contour lines enter into the strip of paper there and therefore marked at that point. Place the piece of paper along the horizontal axis and plot the points at the correct height. What this simply means is, and note the following, we are using a grid, and this particular grid has plotted each point. After marking off, as you can see, this particular aspect, we now take that strip of paper and place it at the bottom of our x-axis. Note the points A and B. And note on the vertical axis, we have put in our contour intervals, including the heights of each point. What I want you to focus on, and let's change the color here, is the following points. Each point has been marked off clearly according to the height of the map. And you'll note that immediately these points are forming a shape. And what do we have to do with that shape? Join the points as a freehand cross-section. This is important, guys. A freehand cross-section means you will not use a ruler. Notice how from A to B, point A to point B, a line has been drawn that joins the points. And this is the shape of the land. What we are able to see is that from A to this particular point is a gentle slope. The gradient increases, creating a summit, and then decreases, creating a flat plane. Note the horizontal axis. is 1 is to 50,000. The vertical axis in this case is 1 centimeter represents 20 meters. And with this, guys, these are the essential elements that you will have to follow in order to construct a cross-section. In the summary, you should remember the following, that the vertical axis is represented by the contour intervals. The horizontal axis, which is your x-axis, is always 1 is to 50,000. And with that, I'm going to hand over to Abram for a quick break.
Thank you so much, Mindsetters. Remember, if you're struggling, I'm here to help you on facebook.com/learnextra. But you can also help other Mindsetters on the page that are struggling. So in the meantime, you have the challenge question handy. If you don't, check it out on Facebook. We'll see you after this break. Welcome back, Mindsetters. Now, I hope you are trying out the challenge question because it's a bit easy, but it's challenging at the same time. It needs you to think and give us the right answer on facebook.com/learnextra. If you just joined us now, you're a bit late, but I'm sure that with Kamlin, you can still catch up.
Thanks, Abram. Guys, welcome back. I hope you've been following. And that challenge question, you may think you know the answer, but I want a specific answer to a geographer. So let's look specifically now at what we've been doing. We've been looking at cross-sections and how you construct a cross-section. I want to do a quick example of the types of sections that you will be able to see. In this example, note the following. We will look at different types of landforms using contours and cross-sections. What does a concave slope looks like? In the exam, you'll be surely required to describe some of these cross-sections. And I will use some of these examples to show you what terms I use to describe the cross-section. In this case, we will look at a concave slope. Note the slope here. We start off on a gentle, then it becomes steep and becomes gentle again. Look at the contours. Your highest point, which is 900 meters, note the closeness of these lines. And as you move further away down slope, the contours start increasing. The contour interval remains the same. However, the distance between the contour lines changes. In this particular example, you will note that the contour lines start off being close together and eventually become far apart. What does this mean? It means that it starts off as a steep slope and then becomes a gentle slope. And this type of slope is what we refer to as a concave slope. Note, close contour lines and then gradually becoming far apart. The next example, a convex slope. In this example, you'll note the following. A convex slope starts off with the contour lines that are far apart, and gradually they come close together. Note the shape of a convex slope, starting off gradually with the contour lines being far apart and then coming closer together to create a level of convexity on that particular slope. So what is our key elements that we must remember now? We should remember that when contour lines start off far apart and gradually come close together, this is a convex slope. When contour lines start off close together and gradually become far apart, that is a concave slope. You will be asked on a cross-section to determine the types of slopes that you are drawing, as you will see in our example today, which is the manual cross-section. Let's go on to another example. Different types of landforms using contours and cross-sections, and again, a cross-section with different slopes. Note the shape of the landscape. That's perfect. The steep slope. Note the distance of the contour lines, all closely packed together. And note the slope is gradually steep. If we look on the other side of this particular slope, you'll note it has a step-like or terrace pattern. This particular terrace pattern, note, is almost like a step-like pattern. Note how the contour lines are shaped on a map. They are grouped together in pairs. And when contour lines are grouped together in pairs with a gradual distance between them, we refer to this as a terraced or step-like slope. Note how the landform is shaped. Almost like a step-like structure. In this example, we should remember that when contour lines are closely packed together, we get a steep slope. And remember, when contour lines are grouped together in pairs with a gradual distance between them, we refer to it as a terraced slope. The key elements of this discussion is for you to be able to identify a concave slope, a convex slope, a terraced slope, as well as a steep or gentle slope. These are the essential elements that assist us in order to understand better the cross-section. Now, what we're here for today, guys, is to ensure that you understand how to manually construct a cross-section. Let's look at today's example. To improve your skills, we will refer to the topographical map of Three Sisters. Three Sisters is in the Klein Karoo region, which is a very dry region and is associated with karst landscapes. So what we will be seeing is different types of formations, especially horizontal type formations, which you've been doing in Geomorphology, grade 11. The first question we will focus on is to draw an accurate cross-section from the diggings in B6 to the spot height C6. Before we go to the map, I want you to focus on the following. The cross-section will deal with this particular topographical map and the diggings to that area there. Note the distance between the 2 points which we will be constructing. Note the closeness of the contour lines which we must be able to identify. Note the from point in this example is the diggings, which represents, in this case, a mining area. And the other point is at spot height 1456. Without further ado, I'm going to now go to the manual cross-section that we will construct using an actual topographical map of Three Sisters. So, when looking at this particular section, you will see the following. Our diggings, which is located on the topographical map at this point in block B4. Right, here's our diggings. And we have been asked to construct the cross-section from the diggings, which is a mining area, to spot height 1456. If you've been listening, guys, the first step is to draw a line between the 2 points, like so. So I'll place my ruler like so, and between the diggings and the spot height, I will draw a line. Now my cross-section will determine the shape of the land surface. Because this is a topographical map, it gives us the top view or aerial view of the land surface. What we want to determine is between this point and this point, which is spot height 1456, what is the shape of the landscape? In order to do this, I will firstly get a strip of paper. Using my ruler at the bottom section, I will now use a strip of paper to determine. Note, I'm placing the edge of the paper onto the line that I've constructed. The first step is to ensure that you mark off your beginning point and your end point. And in this example, the digging, which I'm writing down, and in this case, my spot height, which is 1456. Remember, a spot height gives you an actual altitude at that point. Now, what do I have to do? I have to determine between these 2 points, all these contour lines. Note, I'm pulling the strip of paper away, and trying to determine how many contour lines are here. What I've also got to determine is, are the heights decreasing between the digging and that point? Are they increasing between 1419 and there. Note, these contour lines look deceptive, but I'm going to show you a way to easily understand and identify the heights. When determining the first particular contour line, it is a brown line, and the first brown line that crosses is this particular brown line. You will note it flows, and I've got to mark it off here. What is the height of this line? To determine the height of this line, I'm going to pull my strip of paper away and look for the next possible height. You will note that as you move along this line, there is no heights given. No heights given. So I will look for the next possible contour line. And what do I see towards the north is 1160. Let me circle that for you. And that particular line is continuous along this map. And if you note, this is a river system. As you move away from the river system, you should remember the river flows at its lowest point. So if this is 1160, my next line, which is this line, the line in question, is going to be 1180. And remember, that is meters. How did I get 1180? We have established that the contour interval on any topographical map in South Africa is 20 meters. So the difference between 1160 and as we increasing towards this point is plus 20 meters, 1180. And from this point, it becomes so much easier. You should note that as we move along the lines, all these lines will be increasing by 20 meters. Note, I'm marking on my strip of paper the points where the contour lines cross my strip of paper. I should remember the following. If I look at this particular height and the height at this point, the land surface is increasing in height. Each line that passes through my strip of paper is actually increasing by a height of 20 meters. So simply put, my next height is going to be 1200. My next height is 1220. And note as we move along, 1240. Note my 20 meter intervals, 1260. And then as we move along, you will note that this particular contour line is increasing until we've reached this particular point. At this point, which we're going to mark off as X, we should note it's a spot height, and therefore its height is 1419. This is important because these are particular heights that we'll have to establish on our cross section. Moving on, now the heights start decreasing. And for each line that crosses this particular page, we will show you as follows. So what I should remember is, as I move up and further down, now my heights start decreasing. And if they're decreasing, you should note that these lines are now decreasing. So we have now 1260, 1240, 1220. Now note, when I come to this particular stage, I'm looking at this particular line, and it is a common line which touches my line, which is constructed between the 2 points, both at this point and at that point. So it's the same line. What I should be able to determine is that this particular line occurs twice, 1200, and again at this point, 1200. Note, as you move away from the diggings towards the point spot height 1419, the heights are increasing. Once we reach this peak, the heights start decreasing to the point where this particular line, if I pull away my strip of paper, occurs twice along that line. And note, as you move away from 1220, now the lines start increasing again. Already you should be able to determine the shape of this particular landscape. And note my intervals. I've now established that there's many lines that exist, and sometimes I want you to focus in this particular area here now, that in 1492, the closeness of these lines at this particular point means that the slope is so steep that it's almost at a 90-degree angle. What happens is you have a situation where the contour lines start getting much closer together than normal. Although these are steep slopes, because the contour lines are closer together than as opposed to this area here, you'll note that this brown here is darker. What it should suggest to you is that this is an almost vertical slope. Now that we've got our particular markings, we can determine that our highest height at this point is the last point, which is 1456. And as you move away, you'll note that it's decreasing, then increasing to a point of 1419, and then it's decreasing again. What you should remember is that our from point is the digging. We are required to draw the cross section from the digging to spot height 1456. And I'm going to draw a rough cross section and show you how we actually get to the cross section. To do this, remember, the first step is to determine a vertical axis, like so. Our horizontal axis will be drawn like so. Always remember, the horizontal axis has a scale of 1:50,000. Let's look at the vertical axis. We establish our vertical axis in centimeters. For every 1 centimeter, we should note that there's a 20-meter increase. So what I'm going to do is create 1 centimeter intervals on my vertical axis, like so. Each centimeter will represent 20 meters. I'm going to put in a few more points just in case we have the situation of higher points. Note that my vertical scale is 1 centimeter represents 20 meters. Now, let's go back to our strip of paper. What we've established is that our highest point is 1456. Our lowest point in this example is 1180. And you'll note that if we have to look at our topographical map again, the diggings is a lower point. So it has to start off from the digging. So what I'll do is as follows. I will look at my vertical scale and start interpolating the particular values that I've received from my cross section. The lowest point, and my advice to all of you drawing cross sections is always start off at 20 meters below the lowest point. What does this do? This assists us so that the horizontal axis is not touched. So in this case, my lowest point is 1,180 meters. I will start off at 1,160 meters. And as I progress along, I will increase each one by 20 meters. And note my intervals: 1, 2, 2, 0, 1, 2, 4, 0, 1, 2, 6, 0, 1, 2, 8, 0, 1, 3, 0, 0, 1, 3, 2, 0, 1, 3, 4, 0, 1, 3, 6, 0. Remember, my highest point is at 1456. So I will need a few more points to accommodate that height. And remember, I'm at 1 centimeter intervals, so I'm going to increase the number of points on my vertical axis, like so. Note, I'm creating 1 centimeter intervals. Further on, 1380, 1400, 1420, 1440. And I'm going to stop at that point because we know already that 1456 is our highest point. The next step is to take my strip of paper and place it exactly onto the line of my x-axis. Note the digging. The digging would fall exactly on the vertical axis. We've already established that, and if we go back to the contour, the digging falls below the first line of contour. So it has to be at a lower point. I'm going to put my digging between 1160 and 1180. My first point on this contour line, 1180. Note, in line with 1180, I mark off that point. 1200, I will mark off the point there. 1220, and I will mark off the point there. What I'm currently doing is interpolating points of contours onto the map. And note the closeness of these lines. If I want to be more accurate, I will then use my ruler like so. 1260. My next point is 1419, which is closer to 1420 and just below. Note, I've marked off that point. My next point again is 1260. And I'll mark it off there. 1240. 1220. 1200. And note, in this example that we've used, the 1200 line, which we'll go back to, occurred twice. Note it crossed my cross section at that point as well as that point. So it occurs twice. So when I take my ruler onto that, I will now place it at 1220. And note, immediately after that point, the points start increasing again. And note the steepness of these slopes. One, 240, and my last point, and I'm going to draw this at 1456, which is out of the cross section. Now, once I've interpolated the points, this is what I have: a rough cross section. From the digging, which is on my y-axis, note there's my y-axis. The digging falls below 1180. From this point, I will now draw a freehand cross section. Note, I am not using my ruler. Now, note that I've missed these points and I will lose marks for that because I've deviated from the shape. However, what I'm going to do is quickly erase that section so that I can redraw that particular points for you. Let's mark off the points again. And then continue. And now we've got the shape. Once we've established this, and I want you to note that this exaggeration, which is a section we will do later on, is showing you the shape of the landscape. This is what we call a cross section between diggings and spot height 1456. When we've done this accurately, you should determine the shape of the land. Note, there is a steepness of the slope, and if we look back at our contours, the steepness of the slope, because the contour lines are close together. Let's go back from there to there. Note the decrease as you move away. The contour line starts spreading out, and look at how it decreases downwards to the point where you reach 1200, which is there. And note, there is a point of deviation or a gap between these two, and it's the same line that crosses, and then from that point to that point, there is an increase in height, and you'll note the increasing height. Now this, learners, is a accurate cross-section showing you the shape between the diggings as well as spot height 1456. When we do this particular aspect, I want you to focus on the following. The following labels will give you the full marks. The scale of the x-axis, which is 1:50,000. The scale on the y-axis, 1 centimeter represents 20 meters. Remember the hint and tip. Always start off at 20 meters below your lowest height on the strip of paper. In this case, we've had 1180, and my lowest height then becomes 1160. My first contour line, which I'll go back to the map, is at this point. Once I've established this particular point, look at the contour line. Once I've established the height of that contour line, and how did I do that? I looked at the closest contour line to this, which was this particular contour line. And if you follow this particular contour line, its height was 1160. So my diggings lie between 1180, which is this line, and 1160, which is that line. Anywhere in between. Note my construction. At that point, I have my diggings, and I will label that part my diggings. Remember, a diggings is another term on a topographical map for any mining activity. In this case, my final point is here, spot height 1456. And this, ladies and gentlemen, boys and girls, is what we call a cross-section. Right? Let's now move back to the screen in order to further identify what it is that we are required to do. So guys, we've been able to draw a cross-section, and I'm going to quickly draw for you a rough sketch. We've managed to answer this particular aspect. Now what I'm going to do for you is draw the actual cross-section. Remember, our diagram is as follows. And the y-x-axis, okay? And our shape of our cross-section, we're going to draw with that particular one, was as such. This is roughly the shape of the cross-section. Let's go back to the questions. Indicate the position of the N1 on your cross-section. Let's go to the map. And I'm going to look at the N1. Note the N1, which runs across my line. It falls between the diggings and the contour line. So, going back to the cross-section, and I'm going to interpolate the N1, which is at this point. N1. The next question. Indicate the position of the non-perennial river on your cross-section. Let's go back to the topographic map. And when we look at the topographic map, you'll note the following. The non-perennial river is in that area there and lies between the two peaks. So, back to my cross-section, and my non-perennial river lies in that area there. Non-perennial river. Let's go further down to the next question. Identify this landform. Note, two areas of high peaks with a river or non-perennial river that flows in between. This particular landform we refer to as a gap if there is no river. In this case, there is a river flowing, so we call this a poort. And with that, we are able to understand the cross-section. So guys, this is essentially the elements of drawing and interpolating a cross-section. Firstly, to construct, you'll need a strip of paper, and then secondly, you should be able to identify the points on a map. I'm going to hand over to Abram for a quick ad break.
Thank you so much, Kamlin. And guys, thank you for your questions, Tolani, Ratulo, and Olibacheng Seribe. Thank you for your questions. We'll take them after this break, so stay tuned. Welcome back, Matrix. Now remember, you still have got a chance to enter for the Casio calculator to stand a chance of winning this awesome calculator. The notes are provided on Facebook. There's a link on Facebook with the competition post. Remember, you have up until 4 p.m. tomorrow to enter. Kamilin?
Thanks, Abram. Guys, challenge question time. Challenge question time. And I'm going to go straight to that challenge question again. Why is using a globe important to a geographer? Any geographer in any classroom will have a globe. A globe tells me so much about the earth. Remember, geography is an earth science. Why is it important? Because I'm going to call Abram to assist me to explain this to you. So Abram, if you can join me. What is this, Abram?
It's a globe.
Yeah, and it's the earth. And in order for us to understand this globe, what you should remember is the following. The globe gives us an accurate direction as well as distance across the Earth's surface. Note, we can see different continents as well as land and sea masses. What is unique about most globes is that actual distances between land masses and sea masses are given. A further hint and tip for you to remember is the following, that this particular bulge is what we call the circumference of the earth. And I'm going to ask Abram to assist me to turn it this way. Now, when looking at the earth from a top view, you should note the following. The circumference of the earth is at the equator. And this is what we call the earth's bulge. Did you know that the circumference of the earth at the equator is larger than the distance between the north to the South Pole? What does this mean? We've believed that the Earth is spherical in shape. As time has moved along, we have learned that because of the diameter between the North Pole and the South Pole being smaller than the diameter of the circumference of the Earth at the equator, the Earth has an unusual bulge. And therefore, we say that the Earth is spherical, but it's not perfectly spherical. We have a more geoid shape. Did you know that, Abram?
No, I didn't.
Well, there's always something that we can learn.
So true.
Thanks, Abram.
You're welcome.
So guys, with that, I want to quickly revise what we've done today. We've worked with cross-sections. Together, we have identified the key aspects and components of constructing a cross-section. What are those key aspects? Remember, you first need to have a topographical map. You will need a strip of paper, and you will need a pencil. Once you've got those elements, determine firstly the contour interval. Once you've determined the contour interval, you should be able to mark off on your strip of paper the different contour lines. Once you've been able to do that, determine the highest height, determine the lowest height. And once you've got that, you construct on your X as well as Y axis the cross section. Key components to remember the following. The x-axis is always at 1:50,000. This is taken from the topographical map. The y-axis, dependent on the contour interval we construct. And in most cases, the contour interval is 20 meters. Therefore, on my y-axis, I must ensure that my scale is 1 centimeter represents 20 meters. Once I've got that, I place at the bottom on my x-axis the strip of paper and mark off each and every point as I've indicated. Abram, are there any questions?
There's one from Olibacheng saying, what is the difference between contour intervals and length between the contour lines?
Okay, good question. Remember, there's two components that we're talking about. When we talk about contour intervals, that is the difference between two contour lines in terms of altitude. when we're looking at a topographical map, note we are looking from a top view. In order to accommodate the 3 dimensions, we now look at contour lines. When we talk to a contour interval, we are talking about a 20-meter increase in height. When we talk about distance now, we are describing the shape. And in this example, the example would be the distance between, if it's further, it's a gentle slope, and if it's closer, it's a steep slope. Abram?
Thank you so much. That's where we have to end it today.
Thanks, Abram. And thanks, guys, for a good show. Back to you, Abram.
Thank you. Remember, Mindsetters, next week, you guys are on holiday, but rather the study holiday. You're going to be studying with us, and next week, catch our revisions from Monday to Thursday, and don't miss any of them. We love you, and peace.